Hello and welcome students to this session. Yeah, good afternoon. So today we are going to solve 40 questions, 40 most important questions of wave optics and ray optics, both the chapters. And as you know that optics is very important. Okay, almost out of 250 questions, 19 questions were from ray optics and 11 questions were from wave optics in 2026 January attempt. Hello Black Mystery. So you see, out of 250, total 30 questions from optics. So optics is anyhow you cannot avoid to skip this chapter. So in this live we have brought a good collection of the 40 questions, okay, which covers different varieties, most important things, okay, everything is there. Yeah. Hi. So let us begin. We are going to cover two chapters, ray optics and wave optics. First we will be solving questions of ray optics and then wave optics. And also in wave optics the varieties are less. Okay, in wave optics if you talk about most of the questions are formula based. Okay, if you understand fundamental things, okay, that's all. In ray optics more number of varieties are there. Okay, lens is there, then mirror is there. Okay, multiple lenses sometimes they are placed. Okay, lens maker formula is there. Okay, many things are there in ray optics. So comparatively if I say ray optics is a heavier chapter, wave optics concepts are lesser, but yes, it is also important. But ray optics is having the more weightage. Almost as I mentioned, it was having 19 questions and it was having 11 questions. You can say ray optics is certainly more important as compared to the wave optics, but still wave optics is also important. So let us begin with the first question. An object is placed at a distance of 12 centimeter in front of plane mirror. So let us draw a plane mirror. Here is our object. This distance is given as 12 centimeter. The virtual and erect image is formed by the mirror. Yes, here the image will be formed. Now the mirror is moved by 4 centimeter towards the stationary object. So object is here. I moved the mirror here. How much? 4 centimeter. So this distance is 4 centimeter. The distance by which the position of the image will be shifted. Initially the image was here. How much was this distance? If this was 12, this is also 12. So this was total 24 centimeter. Now the object is here at a distance of 8 centimeter. Image will be here at a distance of 8 centimeter. How much is this total distance? 8 plus 8, 16. It means the image was here, it moved here. How much distance? 8 centimeter. So 8 centimeter and that distance is towards the mirror. Yeah, 8 centimeter towards the mirror. Second option is correct. Hello, Kiran. These questions are based on a January session of JEE, not based on January session of JEE. Overall, complete PYQ collection. From that we have selected these 40 questions. Yes. Yeah, here we are having second option. Okay, 8 centimeter towards the mirror. The image is shifting towards the mirror. The distance by which the position of image will be shifted. Okay. Next question. A light ray is incident at an angle θ1 on system of two plane mirrors. M1, M2 are the two plane mirrors inclined at an angle of 75 degree. After reflecting from mirror M1, it again reflects from M2. Okay, the total deviation is. So we know in case of two mirrors, the net deviation is 2 pi minus 2 theta. Remember this formula. Net deviation is 2 pi minus 2 theta. So if I write here, it is 2 pi minus 75 into 2 is how much? 150. This is 360. So this is 210 degree. Now somebody may say, should we take 210 or should we just take 150? Means total is 360. I am saying net deviation is 210. So it should be 210 or 150. It should be 210 actually. 2 pi minus 2 theta, because it represents how much is the total deviation. Okay, not just the net, you can say the angle between the incident and the final ray, not like that. It shows how much is the total deviation in that sense. So total is 200, 2 pi minus 2 theta. Is tomorrow CS exam, sir? Sir, tomorrow CS exam. Okay. So this is, yeah, 25th is there tomorrow. Yeah, you have computer science exam. Okay. I think you have prepared for that, or you want to go. If you want to go and watch this in recorded, it's okay. A convex mirror of radius 30 centimeter forms an image that is half the size of object. So magnification is 1 by 2. It should be plus 1 by 2 or minus 1 by 2. It's a convex mirror, na? It should be plus 1 by 2. So magnification is plus 1 by 2. Now you write it. Magnification we know for a mirror minus V by U. Okay, V and U relation we got. So I can say V is equals to minus of U by 2. Now use the mirror formula. What is that? 1 by V plus 1 by U is equals to 1 by F. What is the focal length? Radius of curvature is 30 centimeter. Focal length is plus 15. Okay, convex mirror, therefore plus sign will be there. Now put it. 1 by V. What is V? Minus U by 2. So minus U by 2 plus 1 by U is equal to 1 by F, that is 1 by 15. What it is now? Minus 1 by U is equal to 1 by 15. So U comes out to be minus 15, minus 15. Clear? Yeah. Please do BitSat 2025 questions, as this time BitSat was very tough. Please make for BitSat 2. No, we are planning for JEE mains only. Okay, so we have not launched any series yet for BitSat, so we will be covering only JEE mains thing. If you are preparing for JEE mains, BitSat will be okay for you. Okay, BitSat will be okay. It's not a big deal. A thin cylindrical rod of length 10 centimeter is placed horizontally on the principal axis. Now the most important thing in ray optics is draw the diagrams properly. Okay, if you want to get the right answer, draw proper ray diagrams. Okay, not ray diagrams, proper diagrams I am saying, and then use the formula with proper sign convention. Sign convention is the key. If you are confused whether it should be plus or it should be minus, then it's not good. Okay, sign convention is must always. Now let us do this. A thin cylindrical rod of length 10 centimeter is placed horizontally on the principal axis of concave mirror of focal length 20 centimeter. So this is a concave mirror of focal length 20 centimeter. This is the principal axis. Now here what is placed? Thin cylindrical rod of length 10 centimeter. Where it is placed? The rod is placed in such a way that the midpoint of the rod is at 40 centimeter. Here is my 2F, or I can say C. The midpoint of the rod is here, so the rod would be somewhat like this. What is the total length of rod? 10 centimeter. So this point will be at, this is 40, so this will be 35. Okay, it will be 45. Clear? Yes, the length of the image formed by the mirror will be x by 3, the value of x is. Now what we need to do? Find the image of this point, this end of the rod, find the image of this end of the rod, subtract the two positions, you will get the length of the image. Sir, when is the faculty review of Arjuna 2027, and batch price right now is only, somebody was saying something, I think the comment is not there now. I think in few days we are going to have that live session, I think. Okay, so all the details will come there soon, just within few days. Yeah, good evening Arpan. Convex magnification is, yeah, convex mirror magnification. Yeah, you are right. Now I need the length of the image of the rod. So what I will do? Find the position of this, find the position of image of this point, find the position of image of this point, then subtract the two, you will get. Basically what is happening, C image will be at C only. Okay, this image will be somewhat here, this image will be somewhat there, and the difference between that will be the length of the rod. Now use the mirror formula 1 by V plus 1 by U is equals to 1 by F. I am writing for this end. Let us take this is A, this is B, or 1 and 2. Let us mark that as 1 and 2. So let us take this is my 1, this is my 2. So 1 by V1. What is U? Minus 35. So minus 1 by 35 is equals to what is F? Minus 20 minus 1 by 20. So from here 1 by V1 is equal to 1 by 35 minus 1 by 20, like this. Now write V2 for this second. Okay, this was for from here I will get V1. Now write for V2. Let me write what is the value of V1 from here. I can say this is 35 into 20 divided by 15 with a negative sign. 5 into 3, 5 into 7. This is minus 140 divided by 3. This is my V1. Now same thing for V2. Let us write that 1 by V2. What is U2? Minus 45. Okay. So minus 1 by 45 is equal to, write F. What is F? Minus 20, like this. So my 1 by V2 is equal to 1 by 45 minus 1 by 20. Now write V2. So V2 comes out to be 45 into 20 divided by the difference is 25 with a negative sign. Now 5 into 9, okay, 5 into 4. Now 25 is gone. 5 into 9, 5 into 4. What it is? Minus of 36. I got V2 and V1. Take the difference. That will be the length of the image. So length of the image comes out to be, this is the difference of the two. Okay, 36, and what it is? 3 into what I can do is 4, 20, then it is 6, then 2, 6, 6 like this. 6, 6 like this. Then take the difference of the two. What it will become? 36 and 46. This will be 10.33 like that. From there you can find easily what is the value of X. Sir, batch price is reduced, then Vishwas Divas rate to 4200. You are talking about English batch price? I'm not sure, because it should not be like that. Is there any glitch? I don't know. There should not be any glitch. If it is there, I'll check with the team. If it is so, I'm not sure, because on Vishwas Divas it was 4800. Huh? Yeah, it was 4800. Let me check. Okay, I'll check with the team. If there is some issue or like that, we'll confirm. Car B overtakes car A at a relative speed of 40 meter per second. How fast the image of car B appear to move in the mirror of focal length 10 centimeter fitted on car A. So let us take, this is the mirror which is fitted on car A. Okay, so the convex now, like this. So this is my car A, which is moving like this. Now car B, this is my car B, and it was moving with relative speed of 40 meter per second. Now when we relate the velocities, we relate the relative velocities of the object with respect to mirror and the image with respect to mirror. Okay, because U and V are the relative distances, so the relative velocities will be related. Now car B appears to move in the mirror of focal length 10 centimeter. What is the focal length here? 10 centimeter. When car B is at 1.9 meters away from car A, what is the velocity of the image we need? Now how we relate the velocity of image for a mirror? So for a mirror, on the principal axis, the velocity along the principal axis, we write velocity of image is equal to minus of magnification square into velocity of object. How I got this formula? You can try it easily. 1 by V plus 1 by U is equals to 1 by F. Differentiate it, minus 1 by V square dV by dt minus 1 by U square du by dt is equal to 0. From here, dV by dt is velocity of image, du by dt is velocity of object, and V by U is minus V by U is my magnification. Okay, so from here I can say dV by dt is basically equal to minus of V square by U square into du by dt, which will be written as velocity of image with respect to the mirror is equals to minus m square velocity of object with respect to mirror. This is a quick derivation. I'm rubbing it now. This we got. Now basically what I need magnification for this condition, and there I'll get, and these are velocities with respect to mirror, like that. So I need magnification. So use the mirror formula. 1 by V plus 1 by U is equals to 1 by F. What is V? We need to find. What is U? U is 1.9 meter. Everything else is in, okay, let us put in centimeter. I'll take this as 190 centimeter. So this is U as minus 190 is equals to 1 by F. What is F? F is 10, so plus 10, like this. So 1 by V is equals to 1 by 90, 1 by 190, it will go to the right plus sign, plus 1 by 10. Now 190 as LCM, 1 plus 19. So 1 by V is equals to 20 by 190. This is my 1 by V. I need magnification. Magnification is equals to minus V by U. What is minus V? So minus of 190 divided by 20. Okay, this is my minus V. What is U? U was minus 190. So divided by minus 190. Clear? Now from here we got the magnification as 1 by 20. Magnification is 1 by 20. Then I'll say that my velocity of image, see here, my velocity of image with respect to mirror is equals to minus m square, na? Minus, what is m? 1 by 20. 1 by 20 square into velocity of object with respect to mirror, that was 40. See this, what it is now, this is minus 1 by 400, this is 40, 1 by 10. Okay, okay, this is velocity of image with respect to mirror. Yeah, now next is this, okay, this is velocity of image with respect to mirror. This is minus 1 by 10. What is the velocity of object? Okay, but I need, okay, 0.1 only. I need only the relative. I was thinking we need to find with respect to ground. Here it is mentioned with respect to mirror only, and we need to find with respect to mirror only. So that is 0.1 meter per second only. Yeah, yes, yes, yes. If it is asked here with respect to ground, then we need to consider the velocity of mirror only. Then I need to, this is relative velocity. Here it is asked relative only, therefore I marked 0.1. If here it will be asked with respect to ground, then I will be considering the velocity of mirror here, writing it like, you know, velocity of image minus velocity of mirror is equals to minus 1 by 10, like that. Okay, I will be writing, and from there I will be finding the velocity of image. But we need to find relative velocity only, therefore like this. Sir, which phone do you use? Why you want that detail? I don't know. Somebody asked which bike, somebody asked which phone it is. Okay. Consider a light ray traveling in air is incident into a medium of refractive index root 2n. So here we are having a light ray which is incident on a medium like this. The incidence angle is twice that of the refracting angle. What we need to find? The angle of incidences. So if it is I, here it is mentioned that this is I by 2. Refracting is half, okay. Now use the Snell's law, simple. Mu1, that is 1, it is air, okay. Air is 1. Mu1 into sin I is equal to mu2, what is that? Root 2n into sine of r. What is r? I by 2. So you can put that. So now here sin I can write as 2 cos of I by 2 into sine of I by 2. And this comes out to be root of 2n into sine of, what is r? What is that? I by 2. Now sine I by 2 and sine I by 2 got cancelled. From here I can say cos of I by 2 comes out to be root of n by 2. So what it is now? 2 into cos inverse root of n by 2. I comes out to be 2 into cos inverse of root of n by 2. Fourth option. Sir, please say which phone. They did not mention mirror type. Yes, this is the point. This is what I was waiting for. Here they did not mention what is the mirror type, but it is already understood now. We use convex mirror. It is already understood that we use convex mirror. In cars, in bikes, which mirror is used? Convex mirror. This is what is taught, why we use convex mirror. You remember that question? I think it was in 9th class, huh? Why we use convex mirror in cars and like that. Yes, fourth is the correct answer. Good, Kiran. And Deepak. Yes, great, Deepak. Why again and again somebody is try to ask which phone I am using. Just I get confused with formulas between lens and mirror. What should I do? Just try to write 2-3 times, try to remember it. Okay, do more practice actually. Confusion, why the confusion happens is due to lack of practice. Okay, now you just try to remember the formulas, but you don't practice. Okay, when the day will come when you have to apply that formula, you will get a confusion. Whether the sign was positive or negative, or which direction we consider positive, which direction we consider negative. Okay, this shows lack of practice only. So just do practice. Yes, remembering formula is also needed. Okay, it's not that that is not needed, but sufficient practice should back that up. Otherwise those formulas you remember and then in the exam hall you will get confusion. It happens. Sir, where you are from? I am from Delhi. In mirror always written objects are closer than they appear in the mirror. Yes. Yes, this is written. It means they are convex mirror. Okay, so in traffic, in vehicles, we use convex mirror only. So if it is not mentioned it is convex mirror, take it by default it is convex mirror. Next question. We have to solve 40 questions and the time is less. Let us increase the speed. Two immiscible liquids of refractive index 8 by 5 and 3 by 2 respectively are put in a beaker as shown in figure. The height of the column is 6 centimeter of each. Okay, a coin is placed at the bottom. For near normal vision, the apparent depth will be. So when you are seeing from here, if one liquid will be there, how will I be writing apparent depth? Total depth divided by refractive index. This is how. But here two liquids are there. Okay, for now accordingly you can write for each of that. So I'll say it will be 6 H1 by mu1 plus H2 by mu2. This will be my apparent, or d1 by mu1, whatever it is. What is H1? 6 divided by mu1, 3 by 2. What is H2? 6. What is mu2? 8 by 5. Yes, I think it is right now. 3 into 2, 2 into 2, 4 plus this is 6 by 6 into 5 divided by 8. So 2 into 3, 2 into 4 like this, and it will become 4 plus 15 by 4. So 31 divided by 4 centimeter. This will be the apparent depth total. Yes, 31 by 4. Yes, Deepak. I want all of you to please solve the questions. Okay, please solve the questions. The time is very less. Huh? Time is very less. 2nd April, the April attempt is starting. For shift in image, should we subtract by 12 only, right? For the shift in image, yeah. If what you I didn't get, like t into 1 minus 1 by mu, like that. Okay, actually is t or actually is d, apparent is d by mu. If the shift is asked, you can subtract that, the two. Yes. Next question. A fish rising vertically upward in uniform with a uniform velocity of 8 meter per second observes the bird diving vertically downward towards the fish with velocity 12 meter per second. If the refractive index of the water is 4/3, then the actual velocity of the diving bird to pick the fish will be. Here you can say the bird is there. Here we are having the fish, like this. Let us take this distance as x, this distance is y. Here the refractive index is 4/3. Try to understand these concepts. Nobody will explain these type of things properly. Trust me. Yes. Okay. Then the actual velocity. Now here this fish is seeing this bird. And what the fish got? The fish rising vertically with a uniform velocity. This fish was moving up with velocity 8 meter per second. This fish is moving with velocity 8 meter per second. Observes the bird diving vertically down with velocity 12 meter per second. So the velocity 12 meter per second is not the velocity of the bird. It is the velocity of the bird which appears to, for the fish. Okay, it's not the velocity with respect to ground. Okay, the bird, I should say the fish sees the bird coming down with this velocity. So this is 12 meter per second. This is velocity of bird as seen by fish. Okay, we need to find what is the actual velocity of the bird. Let us take this velocity is v bird. We need to find what is velocity of the bird. Okay, if I ask you, sit on the fish and tell me, yes, apparent velocity. Sit on the fish and then tell me how much height this total you will see inside the water. Okay, you are inside the water, you will say, sir, this is y. Yes, this is y plus this, you will say it is in air, na? If you are in air, you see is in the water, what will be the apparent depth? It is actual depth divided by mu. But now you are in water, you see is in air, how much this distance will appear? Mu times of x. This will be the apparent height. Apparent height of the bird with respect to fish. Now differentiate this equation. Yeah, this velocity is given as 12. What is dy by dt? What is dy by dt? Minus 8 plus mu times, what is mu? Mu is 4/3. Yeah, 4/3. What is dx by dt? What is dx by dt? This is velocity of bird minus of velocity of bird, because x is decreasing, na? I am just taking this magnitude. Dx by dt is minus velocity of bird. And this is that apparent velocity. It is coming towards, so minus of 12. Understand this equation, most important. If you got this equation, it means your fundas are clear. Otherwise, you will be always confused. From this equation, we can easily get what is velocity of bird. Moving to the next question. A ray of laser of a wavelength 630 nanometer incidence at an angle 30 degree at the diamond air interface, okay, this is diamond to air, it is going from diamond to air, okay, the refractive index of diamond is 2.42 and the air is 1, choose the correct option. Angle of refraction or whether the refraction is possible or not. Okay, let us see. Let us find the critical angle. If the angle of incidence is greater than the critical angle, refraction will happen. What is theta critical? Sin theta critical is equals to 1 divided by refractive index of the denser medium with respect to the rarer. What is the denser medium refractive index? 2.42 divided by 1. So this is my theta critical. What is the angle of incidence? That is 30 degree basically. This is 1 by 2. Okay. Which one is greater? This is greater, na? Sin I is basically greater than sin theta critical. It means TIR will happen. TIR will happen. If TIR will happen, the ray will not refract. Refraction is not possible. Yes. Refraction is not possible. Fourth is the correct answer. Physics is very scoring at the same time. If your fundas are not clear, then physics will be most confusing for you. Specifically these chapters, ray optics, wave optics, okay, these type of chapters. Therefore, understand the concepts nicely. Okay, if the concepts are pakka na, there is zero probability that you will make any mistake in the question. Sometimes if there is silly mistake, it is okay. Otherwise, no mistake can be there. A monochromatic light is incident at a certain angle on an equilateral triangular prism and suffers minimum deviation if refractive index of the material is root 3, then the angle of incidence is. Okay, let us draw an equilateral triangle. This is my prism. Now, here mu is root 3. A ray incidence, let us take like this, suffers minimum deviation. Okay, suffers minimum deviation. It means this angle and this angle both will be equal. Yes, both will be equal. R1 plus R2 is equals to A, we know. For minimum deviation, R1 is equals to R2, that is A by 2. What is A? This was an equilateral triangle, so this angle is 60 degree, so this has to be 30 degree. Now I know this angle is 30 degree, this angle is I can use Snell's law here, can relate I and 30, yes. So I will say mu1, that is 1 into sin I is equals to mu into sin of R. What is R? 30. So this is root of 3 by 2. I comes out to be 60 degree. Now you are telling 2 pi minus 2 theta. Oh no, before video the angle between mirror problem you told 2 pi minus theta. I think by mistake I would have written if it is like that. The angle of deviation between the two mirrors, okay, when the ray incidence, that is 2 pi minus 2 theta. If it was there, I don't remember exactly. Okay, in hurry I would have written by mistake. The total angle of deviation for the two plane mirrors is 2 pi minus 2 theta. Remember it like that properly. Okay. Next question. The exit surface of a prism with refractive index n is coated with a material having refractive index n by 2. Okay. When the prism is set for minimum angle of deviation, it exactly meets the condition of critical angle. The prism angle is. Now, minimum deviation is happening at the same time, critical angle conditions are also met. Okay. Now, let me show you what is happening here. Exit surface of a prism with refractive index n is coated with a material having refractive index n by 2. Okay. Here we are having a material, here its refractive index is n by 2, prism is having refractive index n. Now here a ray is incident such that minimum deviation happens, at the same time this angle is equal to theta critical. What is theta critical here? I can say theta critical, sin theta critical is equals to 1 by, what is that? Relative refractive index of denser with respect to the rarer. What is denser? N. This is n by 2. What is that? 2. So theta critical comes out to be 30 degree. If theta critical is 30 degree, it means this angle is my 30 degree. Minimum deviation condition is also met. This is also 30 degree. This has to be 60 degree. The prism angle comes out to be 60 degree. Sir, what to do when the 5 linear liner theory questions which were asked in JEE Main 2026 Gen? Okay. That 5 liner question was there. I think in the important questions, I took that question. The 5 liner question was there on diffraction pattern, that I took. So there I think how the width of the central maxima will vary and how the intensity will vary, all those things were asked there. That question I took, but in this discussion I don't think I have taken that question. Next question. Thin prism of angle 6 degree and refractive index of yellow light, that is 1.55, is combined with another prism of refractive index 5 degree with refractive index this. The combination produce no dispersion. Okay, the net average deviation produced by combination is, okay, net deviation we need. Net deviation is deviation by first plus the deviation by second, but they are inverted now. So the difference, one will deviate in one sense, another will deviate in the opposite sense. So when you find the net deviation, I will subtract the two deviations. I will say net deviations is equals to the difference of the two deviations. For thin prism, we write deviation as mu minus 1 into theta. So for here, if I write mu minus 1, what is that? 1.5. Okay, here both the refractive index are mentioned as 1.55. I think there is some mistake. Anyways, I'll say here, let us take this as first medium, this is second. Okay, so I'll write this as mu 1 minus 1 into, what is that? A1, okay, and minus mu 2 minus 1 into A2. Take the mod of this. That will be my net deviation. Yes, mu minus 1 into the angle of prism. Perfect. Next question. Region 1 and 2 are separated by a spherical surface of radius 25 centimeter. Okay, this radius of curvature is 25 centimeter. An object is kept in region 1 at distance 40 centimeter. Okay, here the object is kept. This distance is given to us as 40 centimeter. 40 centimeter from the surface. The distance of image from the surface edge is, okay. So where the image will be formed? How to solve this? Just use the formula for refraction on spherical surface. So write it. How we write? Mu 2 by V minus mu 1 by U is equals to mu 2 minus mu 1 divided by R. This is how we use. Okay, just put the values. What is mu 2? 1.4. 1.4 divided by V we want, minus mu 1 is 1.25 divided by U. U is minus 40. Okay, in this direction minus 40 is equal to mu 2 minus mu 1. So 1.4 minus 1.25 divided by R. What is R? Minus 25. Like this. From here we have to do the calculations to find what is V. Achromatic condition, sir. Why must the prism be made of different materials? Example, crown and flint glass. Can you explain what exactly you want? You are talking about this question, these two prisms. Okay. Yes, no dispersion is there in this. I think therefore I was saying that here there was some printing mistake. Okay, here this is 1.55, here also this is 1. I don't know if they are both 1.55, we can take both as 1.55 also. Both also, if it is 1.55, we can put both as 1.55. I don't know the refractive index. If they are made of different materials or made of same material, that is not mentioned there. But for refractive index, it is mentioned here, it is same. If it is same, we can put the same. Now, okay, only calculations are there from this part. So I can say this is 1.4 divided by V is equal to what it is now. It is plus, on the right it will become minus. So minus 1.25 divided by 40 minus what it is now here. 1.4 minus 1.25 is 0.15 divided by 25. Now calculations can be done to find what is the value of V. We get deviation as 0.55. Okay. Okay, if it is like that, you can put just I mentioned here. Okay. Yes, here it is coming as 0.55. Okay, no problem. Next question. A biconvex lens is formed by using two plano-convex lenses. Okay, this is one lens and this is the second lens as shown in figure. The refractive index and radius of curvature surface, curved surfaces are also mentioned in the figure. When an object is placed on the left side of the lens at a distance of 30 centimeter from the biconvex lens, the magnification of the image will be. So here the object is placed. Somewhat here the object is placed at a distance of 30 centimeter. I need magnification. So this is lens. If I know the focal length of this lens, I can find where the image will be formed and then I can say magnification is equals to V by U. But I don't know what is the focal length. Now how to find that? I can use lens maker formula. Yes. First lens and second lens are of different material. So first I will find what is the focal length of the first lens, then I will find what is the focal length of second lens, then these two lenses are in contact, their powers will add, from there I will write what is my final focal length. Okay, that focal length I will use to find what is the distance of the image. Now see this, let us take this is first, this is second. Okay, lens. So first lens, if I use 1 by f1, mu minus 1, what is mu? What is mu? 1.5. So 1.5 minus 1 into 1 by r1 minus 1 by r2. What is 1 by r1? Plus 30. Sorry, what is the radius of curvature, by the way? Okay, 15. So plus 15, it is towards the right. Now, so 1 by 15 minus 1 by r2. Now for this second surface is flat. If a surface is flat, its radius of curvature is infinite, like this. So this is my f1. Now write for f2, I can say 1 by f2 is equal to mu minus 1. What is mu? 1.2. So 1.2 minus 1 into 1 by r1 minus 1 by r2. What is r1? R1 is infinite. So 1 by infinite minus 1 by R2. What is R2? R2 is minus of 12. Minus of 12. Minus like this it is. So it will become plus here. I got F1 and F2. I need the total focal length. Total power is equal to P1 plus P2. So 1 by F equivalent will be 1 by F1 plus 1 by F2. So 1 by F equivalent is equal to 1 by F1 is, here it is 0.5. 0.5 divided by 15. Okay, this is my f1 by f1 part. 1 by f2, it will be 0.2 here, so plus 0.2 divided by 12. I got my equivalent focal length. Now object is here, this is the focal length. Find where is the image. Use the lens formula. Use the lens formula. 1 by v plus 1 by u is equal to 1 by f. What is v? We need to find. What is u? Here it is f equivalent. What is u? U is minus 30. So minus 1 by 30 is equals to, this is my 1 by f equivalent. Put it as it is. this will become 1 by 30. Is it right? Yes, 1 by 2. And 0.2, it is, I can say it is 1 by 5. Okay, it will become 1 by 60, like this. So from here I can find what is my 1 by V. 1 by V comes out to be what it is, 2 by 30 plus 1 by 60. 5 by 60 it will become. So V comes out to be 5. I got V as 5. What is magnification? V by U. V by U. V comes out to be 5. U is my minus 30. Okay. This comes out to be the magnification. Okay, there is a mistake. I think what it is, 2 by 30, 4 by 60, 5 by 60. Oh, sorry, 5 by 60. It is 12. So V comes out to be 12. U comes out to be minus of 30. Now it is fine. 6 into 2, 6 into 5. So minus of 2 by 5. Still the answer is not matching. Minus of 2 it should be. Where I did some calculation mistake. 1.5 minus 1, 1 by 15, yes. 1.2 minus 1, yes, into 1 by 12, that is right. So 0.5 divided by 15, 0.2 divided by 12, yes. 0.2 I wrote 1 by 5, this is 1 by 60 and this is 1 by 30. Oh sorry, sign mistake. Let me write it again. One by V minus 1 by U is equals to 1 by F equivalent 1 by V plus 1 by 30. Okay, minus of minus, that actually that will become plus. Here is equals to 1 by F equivalent. And what was this? What was this? 1 by 30 plus 1 by 60. Yeah. V comes out to be plus 60. Now write the magnification as V divided by U. This comes out to be minus of 2. Yes. Minus of 2 it is. Yes. First option is coming. Yes. Second question, next question, sorry. A convex lens of refractive index 1.5 and focal length 18 in air is immersed in water. The change in the focal length of the lenses. So you write what is your initial focal length, write the final focal length, take the difference. How we write the focal length? 1 by F is equals to mu minus 1 into 1 by R1 minus 1 by R2. This is the lens maker formula. So this refractive index is actually the relative refractive index with respect to medium. So this is basically refractive index of the material divided by the refractive index of the medium. Okay, so when you write the initial 1 by F1, this I am talking about in air. Okay, 1 by F air. What is this? Mu, what is refractive index is 1.5. So 1.5 minus 1, okay, into 1 by R1 minus 1 by R2. Anyways, this will remain constant, so I am not writing that. And this focal length is mentioned to us as 18 centimeter. So this is basically 1 by 18. Now write for the second case. Now this is in water. Change is immersed in water. Okay, so this is in water. Let us take. Now when you write this mu minus 1, this will be relative refractive index of the lens with respect to water. What is of the lens? 1.5 divided by mu water. What is mu water? 4 by 3. Like this, minus 1 into 1 by R1 minus 1 by R2. Okay, and this we need. Now divide these two equations, this equation and this equation. This constant part will get cancelled. this and this will get cancelled, and from here I'll get what is my focal length of that lens in water, and because I need change, so you can subtract the two to find the change. The difference is 54, somebody is saying. Okay. Next question. Okay, now this lens is being cut like this, and initial power is mentioned as P. What will be the power of these individual lenses? Now, what will be the power of these individual lenses? How we write? So, power we relate with focal length. Okay, we write power is equals to 1 by focal length, and this is equal to what? Mu minus 1 into 1 by R1 minus 1 by R2. This is how we write. Okay, and this is anyways, I think this is equiconvex. Yeah, this is equiconvex lens, so this will become mu minus 1 into 2 by R, like it is. So initially the power was P. Now if you cut this lens like this, one radius, one surface, one curved surface is gone. Okay, instead of 1 by R1 minus 1 by R2, it will be just one surface only. R2 will become infinite, so power will become half. So when you cut it like this, power will become half. So this power is P by 2, this power is P by 2, and what is the power of this? Its power is same P only. Both the curved surfaces are there, na? Yes, both the curved surfaces are there. Focal length will not change like this. If you cut a lens like this, the focal length will change. If you cut it like this, the focal length will not change. Focal length depends upon the radius of curvature of the two surfaces and the refractive index of the medium. That is same. So it is like this. Power of L1 is P by 2. This is incorrect. Power of L2 is P by 2. This is correct. Power of L3 is P by 2. This is correct. Power of L1 is P. This is correct. Okay. This is incorrect, which is asked here, which is option 1. Yes. Yes, Swapnil. Great. Okay. I hope you all are getting. Next. But sometimes, you know, the options are such like power of L1 is P, power of L1 is P by 2. It is a common sense that one of them is incorrect or one of them is correct. If such options are there, then why to look for other options? Next question. The same size image are formed by convex lens when object is placed at 20 centimeter or at 10 centimeter from the lens. Means the magnification is same, size is same, means magnification, magnitude is same. So in one case magnification will be plus, in another case magnification will be minus. Okay, so let us take, these are two cases, case 1 and case 2. Here you can say, let us take the magnification is plus m. Here you can say, let us take the magnification is minus m. This is when the object is at 20 centimeter. Okay, u1 is equals to minus 20, u2 is equals to minus 10 centimeter. Okay, and magnification is plus m. This is a lens. Okay, magnification is v by u. So here my v comes out to be minus 20 m. Okay, and here if I write magnification as v by u, okay, I should write v1 and v2. Okay, 1 1 2 2. Here I can say my v2 comes out to be minus of m into u2. u2 is minus 10. Okay, so this comes out to be 10m. This is my v2. Now I need focal length, so you can use the formula 1 by v minus 1 by u is equals to 1 by f. Okay, so for the first, if I write, what is v? Minus 20. So minus of 20m minus 1 by, what is u? U is minus 20. So plus of 20 here is equals to 1 by f. Here you write the same equation. 1 by v, what is v? V is 10m. So 1 by 10m minus 1 by u minus 1 by, what is u here? Minus 10. So plus 10 here is equals to 1 by f. 1 by f. Okay, this equation and this equation, two variables are there, m and f, two variables m and f. Okay, so this is my first equation, this is my second equation. Okay, easily I can solve for the two variables. Sir, why take magnification plus m and minus m? Now it's not that why not minus m and plus m. No, anyway I am not saying m is positive. Okay, that is the thing. Second thing is, here it is mentioned that same size images are there. If same size images are there, means the magnitude of magnifications has to be same, isn't it? This is there. Now it can be first magnification is positive or second is negative or second is positive, first, whatever can be the condition. I took this as plus m. If m is negative, it will come negative. Okay, yes. Yes. So all the conditions are there in this. I am saying all the conditions are there. Although you can see carefully and you can tell which should be positive, which should be negative, that also you can tell here. But that is not needed. Okay, that is not needed that we should go that much in depth. That is not needed here. Can't we just take same sign for both magnifications? No, we cannot take same sign for both magnification. We cannot. How? The two magnifications can have the same magnitude and same sign if the distances of the objects are different. How it is possible? That is not possible, na? Isn't it? That is not possible. It cannot happen that for two positions you are having same magnification and same sign of magnification also, means with positive negative thing. That is not possible. Next question. An object is at distance of 20 meter from a convex lens of focal length 0.3 meter. The lens forms an image of the object. If the object moves away from the lens at a speed of 5 meter per second, the speed and direction of the image will be, okay, velocity formula. An object is placed at distance of 20 meter. This is my lens. Here is the object. This is 20 meter. Focal length is 0.3 meter. So 30 centimeter, or let us write in meter only then, 0.3 meter, because here also it is given in meter then. The lens forms an image of the object if the object moves away from the lens at speed of 5 meter per second. It means the object is moving away from the lens like this with a speed of 5 meter per second. The speed and direction of the image will be, how we relate the velocity of image and velocity of object in case of lens. So velocity of image is equals to magnification square of velocity of object, and this is with respect to lens only. Here my lens is at rest, so they are actual velocities. Here in this case my lens is at rest, so they are actually the actual velocities. This is how we relate. These velocities are along the principal axis. Okay, along the principal axis we relate the velocities like this. This is for along the principal axis only. Basically, first I need to find what is the magnification, then I can talk about what is the magnitude and all. So I need magnification. My object is placed at a distance of 20 meter. 1 by v minus 1 by u is equals to 1 by f. 1 by v minus 1 by, what is u? Minus of 20 is equal to 1 by f. This is 1 by 0.3. So 1 by v comes out to be 10 by 3 minus 1 by 20. So I can say 1 by v is equal to, let us take 60 as LCM, 60, 3 into 20, okay, anyways, 3 into 20 it is, so this is 200 minus 3. So my v comes out to be 60 divided by 197. Magnification is v by u, which is 60 divided by 197 into, what is u? U is minus 20, minus 20. So this is 3, and okay, this is, it will not divisible by 3 anyways. Let us write it minus 3 divided by 197. This is my magnification. So I'll say velocity of image is equals to m square. Take square. So 9 divided by 197 square into velocity of object. What is the velocity of object? Velocity of object is minus 5 towards the negative x-axis. Okay, so I can say minus 5, or if I take that as I cap, so minus 5 I cap, like that. So the velocity of image comes out to be like this. So it is moving towards the lens. Yes. Okay, so the image is moving towards the lens and with this much velocity. Now we can do the calculations and all, and we can see which one is correct according to the magnitude. Away from the lens are incorrect. Can't we, okay, then sir, we can take mod of m in both cases to reduce clashes earlier. No, you are saying why you write mod. Now why you need to write mod here? No, one is plus, other has to be negative. Nah. Even if after solving I may get m to be some negative, okay, that will be accordingly adjusted. If first is negative, second is positive. If first is positive, second is negative. But one thing has to be same, that they has to have the opposite signs and same magnitude. That has to be there. Yes, Swapnil mentioned the answer. Object moves away from the lens at a speed of 5 meters per second. Okay. So Swapnil, I think which answer you are talking about? Previous question? Which answer you are talking about? Question number, this is number is not there. I think you would be talking about some previous question. Okay, here it was one. Anyways. Next question. Find the distance of image from object O formed by combination of lenses. Now here these lenses are there. I need to find the distance of image from object where the final images will be formed. So what I need to do? I need to go step by step. Okay, for that it is 3. That's great. So I have to go step by step. Due to first lens, find the first image. That image will be object for this. Due to second lens, find the second image. That image will be the object of this. Due to third lens, find the image. That I will say is my final image. Okay, let us go step by step. Due to first lens, object, I am using 1 by v minus 1 by u is equals to 1 by f. 1 by v1. So 1 by v1 minus 1 by, what is u? U is minus 30. Minus 30 is equals to 1 by f. What is f? Plus 10. Like this. So 1 by v1 is equals to 1 by 10 minus 1 by 30. Okay. So from here my v1 comes out to be 15 centimeter. Okay. So my first image, where the first image is there, 15 from here. 15 from here, it means at a distance of 12 from here. From here if I talk about, at a distance of 12 means somewhat here, certainly in the opposite sign, but let me mention the image just as a dot. So here is my first image, this is my v1, and now I know this distance to be 12 centimeter. Okay, that will behave like an object for this. Now again use for this. Again use for this. For second, if I write now 1 by v 2 minus 1 by u. What is u here? Plus 12. Towards the right, plus 12. So plus 12 is equal to 1 by f minus 10. From here, I'll get what is my v2. Okay, using that v2, that will behave like object for this third. Again I'll use, do the calculation, that will be my final image, then I'll find the distance. Okay, 3 times you have to use. I think in this question, if I'm not wrong, some mistake is there in the data. Some typing mistake is there in the data. Therefore our answers are not that much coming, properly. I think there is some mistake with the data here. I think it should be something else, either it is 30 or something like that, but you can check, maybe there is some mistake in this data. check these, there is some mistake I think. But anyways, you got the method. Now moving to the next question. This type of question is important, and this type of question was asked in advance also, exactly similar type of question. Let us read it out. An object is placed at a distance of 12 centimeter from convex lens. This is the convex lens, here the object is placed. A concave convex mirror of focal length 15 centimeter is placed. Okay, here the focal length is 15 centimeter. On the other side of the lens at 8 centimeter as shown in the figure. Image of object coincides with the object. Now image of the object coincide with the object. When it happens, the rays which are going, they should exactly retrace their path. Try to understand this point. The rays which are going, they should exactly retrace their path. Okay, again I am saying, for the image and object to coincide, the rays which are going should exactly retrace their path. If it is happening, it will coincide. Okay, from lens, the rays can go somewhat like this. If these rays has to retrace their path, it should be somewhat like, if the image is there without the lens, without the mirror, then somewhat like this they will go, and I will say this has to be center of curvature of the mirror, then only they will exactly retrace the path. Try to understand, this has to be center of curvature, and if that has to be center of curvature, this distance is equals to 2r, which is 30 centimeter. I need this total distance, okay, here to here, what it is, 12 plus 8 plus 30, which comes out to be 50 centimeter. Deepak Bharadwaj is mentioning the effective focal length formula for the two lenses placed at a separation of d. Then you need to find the apparent position of that effective lens also, and then again you have to use that formula with the third lens, and then again you find the effective position of that. It will be very lengthy actually. This question, which was previous year question of mains, it was set like this, that first the images are first images formed at the focus of the that lens, okay, then the rays were parallel, and then finally they were focused. So that data was actually very much, you can say, simplified, given by NTA. Sir, you teach physics so good, learned so many concepts from you, I'll score 200 plus. Okay, if it is like this. Next question. In a compound microscope, the magnified virtual image is formed at a distance of 25 centimeter from eyepiece lens, means image at D. There are two formulas, at D and at infinity. This is the condition for D. The focal length of the objective lens is 1 centimeter. This is F objective. If the magnification is 100, okay, and the tube length of the microscope is 20 centimeter, this is my L, then the focal length of the eyepiece object is. How we write magnification when the image is formed at D? For infinity, we know this is LD divided by F naught FE, but for D, we know this is L by F naught into 1 plus D by FE. Okay, so here, because this is at D, so we have to use this formula, not this. Remember both, okay. Now, what is the magnification? It is 100. What is L? L is 20. What is F objective? Is 1 plus 1 plus, what is D? 25. What is eyepiece? That we have to find. From here, simple calculations are there. Easily we can find what is FE. Moving ahead. In a microscope, the objective is having focal length this, and eyepiece is having focal length this. The tube length is 32 centimeter. Okay, it means this 32 centimeter is equals to focal length of objective plus focal length of eyepiece. The magnification produced by, okay, wait a minute, this is a microscope. Okay. The microscope is having focal length, I was thinking it's a telescope, sorry. There is a microscope having focal length 2 centimeter, eyepiece focal length 4 centimeter. The tube length is L. The magnification produced by this for normal adjustment is, okay. So this is my L. Normal adjustment means image at infinity. Normal adjustment means restrained eyes can see. So image at infinity. So here I'll say my magnification is LD divided by F naught FE like this. Now what is L? 32. What is D? 25. What is F objective? F objective is 2. What is F eyepiece? That is 4. This is the magnification. I read that properly. Thank you for your kind words. The normal adjustment for a refracting telescope, the distance between objective and eyepiece is 30 centimeter. Okay, this is the telescope. Now the distance between the two for the eyepiece lens and the objective. Okay, this is my objective lens. This is my eyepiece lens. This length is given as 30 centimeter. Okay, this is equal to, okay, for normal adjustment, this image, okay, is formed at the focus of the eyepiece. Like this, the final image is formed at infinity. Okay, so this is basically my F naught plus Fe. The focal length of the objective when the angular magnification of the telescope is 2S. Angular magnification is F naught by Fe. So F naught by Fe is given as 2. F naught plus Fe is given as 30. From here we can find what is F naught, what is Fe. Okay. Acha, for the previous question you are talking about. Okay, Swapnil, great. Now we are moving to wave optics. Okay, ray optics we have done. Important 20, I think almost more than 20 questions maybe. Now we are moving to wave optics. Let us do. Light emerges out of convex lens when a source of light is kept at its focus. The shape of wavefront is. Source of light is at focus. Source is at focus. The rays that will emerge, they will be parallel. Yes, parallel rays will emerge like this. For parallel rays, how the wavefront will be? Like this, isn't it? It's a plane. So the wavefront is plane. Fourth option is there. Simple conceptual question. Next question. Two coherent monochromatic light beams of intensities I and 4I superimposed. Difference between maximum and minimum possible intensities in resulting beam is xi. What is the value of x? What is the maximum intensity? Root of I1 plus root of I2 whole square. What is minimum intensity? Root of I1 minus root of I2 whole square, like this. Now write it. What is root of I1? So this is I plus 2I, that is 3I. 3I square is 9I. 3 root I square is 9I. Here it will become what is 1 minus 2, that is 1 minus 1, okay, square, then you will do, it will be 1. What it is now? I need the difference. If you take the difference, it is 8I. Okay, the value of x comes out to be 8. Next question. Sir, are you married? Yes, I am married. Yes, Deepak, perfect. 8 is the right answer. Correct. In Young's double slit experiment, the position of fifth bright fringe from the central maximum is 5 centimeter. Fifth bright fringe is formed at 5 lambda d by d. Okay, so I'll say 5 lambda d by d, and this is given as 5 centimeter. Centimeter converting to meter. The distance between slit and screen is 1 meter. It means this is my capital D. The wavelength of monochromatic light is 600 nanometer. This is my small d. The separation between the slits is, I need what is small d. This is my lambda. This is my capital D. I need what is small d. Now small d I can solve here. Small d will be equal to 5 into lambda. What is lambda? 600 nanometer. 600 into 10 to the power minus 9 into what is d? D is 1 meter divided by 5. Okay. Yeah, everything is fine. 5 into 10 to the power minus 2. 10 to the power minus 2, so 10 to the power minus 7 it will become here. So this comes out to be 60 micrometer, which is option 1. 60 micrometer, small d. Clear? Many questions are solving questions parallelly. Many students are solving questions parallelly. That's great. Deepak is solving, Swapnil is solving. I think if somebody else is also solving, please mention your name. It's good actually. You are coming in live and you are solving the question, means the purpose is there. Perfect. Yeah, Kiran is also solving. Yes. First, using Young's double slit experiment, a monochromatic light of wavelength 5000 angstrom produces fringes of fringe width 0.5 mm. Fringe width means beta lambda d by d. This is given as 0.5 mm means 10 to the power minus 3. If another monochromatic light of wavelength 6000 angstrom is used, the separation between the slits is doubled, then new fringe width will be. Okay, how the fringe width will change? Okay, lambda is changed and small d is changed. Capital D is not changing here. How the fringe width will change? So I will say my beta 1, what is beta 1? 0.5 mm divided by, let us keep in mm only. Let me write like this only. Beta 1 divided by beta 2 will be equal to lambda 1 divided by lambda 2. Capital D is not changed. D2 by D1. What is lambda 1? 5000. What is lambda 2? 6000. 5 by 6 into. What is D1 and D2? The separation between the slits is doubled, means D2 is twice of D1. So 2 will come here. 2 into 3 it is. What is beta 1? Beta 1 is 0.5 mm. 0.5 mm divided by beta 2. So beta 2 will become 0.3 mm here, which is option 4. Me solving with you. Oh, that's great. Great. Neeladrinath. Good. Next question. In Young's double slit arrangement, slits are separated by a gap of 0.5 mm and the screen is placed at a distance of 0.5 meter from them. This is my small d. This is my capital D. The distance between first and the third bright fringe formed when slits are illuminated by monochromatic light is this. So where the first and third bright fringe, na? Yeah. Third, yeah, bright fringe. So third bright fringe will be 3 lambda d by d. And the first bright fringe will be at lambda d by d. The distance between them will be this. How much it is? Okay, this is, we need to find actually. This we need to find. Okay, let us take this distance as my delta y. This I need to find. What it is now? This comes out to be 2 lambda d by d. Now put the values. 2 into, what is lambda? Lambda is, where is lambda? Okay, 5890. 5890, 10 to the power minus 10. What is capital D? 0.5. 0.5 divided by small d is 0.5 mm. Like this. How much will be the 10 through the power then? This will get cancelled. This will be 10 to the power minus 7. Yes, 10 to the power minus 7 and or I can say 10 to the power minus 6 into 1178. Yes, 10 to the power minus 6 into 1178. Break, sir. Okay, just few minutes only, we will wind this discussion up quickly. Okay, it's 6:18. In few minutes, we'll wind this up. Almost, how many questions I took? About 30, 26 or like that. So then Deependra sir will join today, okay, for maths discussion. You'll get a break in between. In Young's double slit experiment, monochromatic light of wavelength 5000 is used. Okay, this is my lambda. The slit are 1 mm apart and screen is placed 1 meter away from the slits. So this is small d and this is my capital D. The distance from the center of the screen where intensity become half of the maximum intensity for the first time is, okay. How we write the intensity? I max, or like this we write, I is equals to I naught into cos square phi by 2 in Young's double slit experiment. How we got this formula, by the way? This is my maximum intensity. We know maximum intensity is equals to root of I1 plus root of I2 whole square. I naught is my maximum intensity. Okay, if you individual intensity consider I and I, maximum intensity will become how much? 4 of I. Okay, maximum intensity. Now if there is some phase difference between the amplitudes, the resultant we will find how? A is equals to, or resultant R is equals to R1 plus root of R1 plus R1 square plus R2 square plus 2 R1 R2 cos of theta, like that. That way if I relate intensity I, that is basically equals to root of I1 plus root of I2, sorry, I1 plus I2 plus 2 root of I1 I2 cos phi. Okay, I1 is equals to I2. From there we can get this formula. This is I0 is my maximum intensity. Now here, when this intensity will become half of the maximum, put this as I0 by 2. This is I0 cos square phi by 2 now. It means my cos square phi by 2 is 1 by 2. Yes, cos square phi by 2 is 1 by 2. It means my phi by 2 is 45 degree. Yes, phi by 2 is equals to 45 degree and phi comes out to be 90 degree, means pi by 2. I need a distance. I need where the intensity will become half for the first time. I got phase difference. First of all, let us find path difference from the phase difference, and then we will say where that path difference will happen. Where that path difference will happen. So this is my phase difference. Find path difference. How we relate path difference and phase difference? Delta phi or phi is equals to 2 pi by lambda delta x. This is how we relate phase difference and path difference. Put phi as pi by 2. Pi by 2 is equals to 2 pi by lambda delta x. Pi, okay, delta x comes out to be lambda by 4. This is my path difference. In YDSC, how we write path difference? Path difference we write as d sin theta. In YDSC, path difference we write as d sin theta, and this sin theta, considering theta to be very small, sin theta is equal to tan theta, we write this as y divided by d. I need distance from the center of the screen where this will happen. That distance is my y. Okay, I need y from here. I'm rubbing it. This is not needed. I need y from here. So I'll say y comes out to be 4 lambda d by d. Sorry, lambda d by 4d. Like this. Now put the values. What is lambda? 5000. Angstrom it is. What is capital D? 1 meter apart divided by 4. What is small d? 1 mm. So this comes out to be my y. Okay. This comes out to be my y. Pi by 2, 2 pi by lambda there, that is lambda by 4. Okay, y comes out to be lambda d divided by 4 into small d. Yes, I think it will come 125 from here. 10 to the power minus 7 minus 4. Yes, 125 it will come. $125 it should be. Do the calculations. What it is? This is 10 to the power 3. If I need the answer in 10 to the power minus 6 terms. Na? 10 to the power 3. So this will become 10 to the power minus of 7. 1 0 I'll take. This is 500 divided by 4 into 10 to the power minus 6. What is 500 by 4? That is 126. 125. Answer is 125. Next question. Consider Young's double slit experiment as shown in the figure. What should be the slit separation D in terms of lambda such that first minima occurs directly here? So here should be first minima. Where the first minima happens? where the first minima happens, lambda d by 2d. Will it be applicable here? No. Why so? The slit separation is comparable. Sorry, the slit separation, the distance between the two slits is comparable to the separation between the slit and the screen. In our assumption where we write first maxima is lambda d by d, second maxima 2 lambda d by d, there we did assumptions that the distance between the two slits is very less as compared to the distance between the screen and the slits. Here it is not like that. If it is not like that, go with the standard method. Standard method means this path length minus this path length has to be equal to lambda by 2 for first minima. This is 2d, this is d. How much is this path length? Root of 2d square plus d square. So root of 5d. How much is this path length? 2d. The difference between the two path lengths, root 5 minus 2 into d, has to be equal to lambda by 2 for first minima. Okay. Now from here you can write what we need from here. We need d, that comes out to be lambda divided by 2 into root 5 minus 2. If you just remember formula without understanding the question, you will not be able to make this question right. So you have to understand concept also to get it right. Sir, take wave question also including. Now waves we have taken already. In marathon we have taken waves already. Okay, waves question we have considered. Here we are taking wave today only optics part we are taking. Okay. EM waves and all I have taken already, Papa, in the marathon. You can attend. As shown in the figure, Young's double slit experiment, a thin plate of thickness 10 micrometer and refractive index 1.2 is inserted in front of slit S1. Okay, here the experiment is conducted in air and uses a monochromatic light of wavelength. This, due to insertion of this plate, central maxima is shifted by a distance of x of beta naught, where beta naught is the fringe width before insertion of the plate. Anyways, fringe width will not change if we insert the plate, by the way. Okay. Now the point is common sense. Where this central maxima should shift. I have inserted a sheet here where the central maxima should shift. It should shift up, or it should shift down. Sorry. It should shift up or it should shift down. Where it should shift, by the way. The ray which is traveling from the upper slit is already traveling a distance extra because of this thin sheet. Okay, upper is traveling extra. Now for central maxima, lower one should adjust that extra, na? So central maxima will shift somewhat up like this. Should shift somewhat up, such that this path length and this path length difference adjust the path difference, optical path difference caused by this thin sheet. What is the optical path difference caused by thin sheet? Mu minus 1 into t. What is the path lengths between these two? Path length delta x d sin theta. So this should be equal to my d sin theta, like this, where y is the shift now. I need y from here. I can say y comes out to be mu minus 1 into t into d divided by small d. Haircut is just fire. Yo, Sumit sir. Hello, hello. Oh, you are back in today's live session. I was missing. Yeah, it should shift up. Yes, Kiran, perfect. I was missing you from previous many lives. I think 2-3 lives you were not there. Sir, for first minima lambda by 2. Yes, Kiran, that was perfect. Somebody mentioned the answer here, d into mu minus 1, yes, into small t divided by capital T. Perfect, perfect. Actually, let me tell you, I don't remember the formula. Even if you directly ask me, this formula, this formula is not in my mind. I just understand the concept. Mu minus 1 into t has to be equal to dy by d. From there, I can write it. Next question. The Young's double slit interface experiment is performed using light consisting of 480 nanometer and 600 nanometer wavelength to form interference pattern. The least number of bright fringes of 480 nanometer that can required for the first coincidence of the bright fringe formed by 600 nanometer. Okay, let us take nth bright fringe of 480 nanometer coincides, or means I will take the distance of nth, coincide means that only, is equal to distance of mth bright fringe of, what is that, another wavelength, 600 nanometer. This is the condition. This is the condition. So just equate that n into what is the location of the bright fringe, nth bright fringe, n lambda d by d. So n lambda 1 d divided by d is equals to, what is the location of mth bright fringe for this lambda 2 wavelength? M lambda 2 into d by d. D by d got cancelled. Lambda 1, or I will say n into lambda 1 is 480 is equal to m into lambda 2 is 600. Okay, what it is? 12 into 4, 12 into 5. So n by m comes out to be 5 by 4. What is the minimum value of n and m? 4 and 5. One time they will coincide, next time they will coincide when n is 10, m is 8. Next time when they will coincide, m is 15, so n is 15, m is 12, multiple of 3, multiple of 4, like that they will keep on coinciding. So first time coinciding means n has to be equal to 5. So first is the correct answer. I have boards. I said physics exam was in 23rd. Okay. It's so easy. Okay, physics exam was easy. That's great. You got the point here? Next. In Young's double slit experiment, the fringe width is 12 mm. If the entire arrangement is placed in water of refractive index 4 by 3, then the fringe width will become. What is fringe width? Lambda d by d. Lambda d by d. Okay. Now when the setup will go in water, what thing will change? Capital D? No, that is the setup, now same setup you are taking, small d. No, that will not change. Only lambda will change. If a light goes from one medium to another medium, speed changes. Frequency will not change. It means wavelength has to change. We know speed is equals to frequency into wavelength. Frequency remains same. Speed changes, we know speed changes, refractive index changes means speed changes. It means lambda has to change. So when this my setup goes inside the liquid, what will be the wavelength? Lambda dash will be lambda divided by mu. Okay, lambda divided by, you can relate this with V1 by V2 is equal to lambda 1 by lambda 2. From there you can write what will be your lambda 2, that will come out to be lambda 1 divided by mu. Okay, so my beta dash will be equal to beta divided by mu. Just what was beta? 12. What is mu? 4 by 3. 9. This is 9. All concept clear? Okay, that's great. Navneet, that's great. Sir, previous question please explain. Previous question didn't understand why minimum is 5. Okay. Niladrinath is asking why here n has to be equal to 5. Now this you got that nth bright fringe has to coincide, means the distance of nth bright fringe for first wavelength is equals to distance of mth bright fringe for the second wavelength. The two has to coincide at one position. I am considering for first the number is n, for second the number is m. So I got n lambda 1 d by d is equals to m lambda 2 d by d. This funda is clear. I hope this is clear to all of you. Now these two distances will remain same because setup is the same na. So these two will get cancelled. So n1 lambda 1 is equals to m into lambda 2. n into lambda 1 is equals to m into lambda 2. What is lambda 1? 480. This is 600. So this ratio is coming out to be 5/4. Now, if n is 5, I know n and m has to be integers. Try to understand. N and m is the number of the bright fringe, that has to be integer. That cannot be fraction. Yes, that is clear. That has to be integer now. If that is integer, what is the smallest value of these integers such that this ratio is 5/4? This is 5, this is 4. Yes. Next possible 10 and 8. Next possible 15 and 12. Next possible 20 and 16. Like that. Okay. Second, third, fourth, like that. By the way, sir, the bridge course will be there for Lakshya batch. Is right? Yes, it will be. So, will you offer basic calculus like basic integration and differentiation and basic vectors, etc.? Yes, it will be there. Bridge course we will start on 28th of March. Okay. There I will be covering the basics of the concepts which are needed for 12th. Moving ahead. Okay, lot of questions are remaining. We need to increase the speed. Next question. A transparent film of refractive index 2 is coated on glass slab of refractive index 1.54. What is the minimum thickness of the transparent film to be coated for the transmission of green light of wavelength this? So, this question is important to understand. Not important means it is conceptually good question. Transparent film of refractive index 2. So, on this, here the film is there and the refractive index of this film is 2. The refractive index of this is 1.45. The minimum thickness of transparent film, how much is this minimum thickness? Let us take this as T. To be coated for the maximum transmission of green light. Maximum transmission means zero reflection. Maximum transmission means zero reflection. So, for this particular wavelength, reflection should be 0. Reflection should be 0 means what? Try to understand. Light is falling. One part reflection from here. This is transmission. Another part from the lower one. So, these two reflected rays, they should form minima. This question was there in test also, I covered that. So, these two should form minima. What is the path difference between the two? You may say this second is traveling 2 mu t. So, path difference is 2 mu t. You may say for minima, this 2 mu t should be equal to lambda by 2. But no. Why? This upper is reflecting from a denser surface, lower is reflecting from a rarer surface. When a wave or a light reflects from a denser surface, additional phase difference of pi is introduced. This upper one is having an additional phase difference of pi, lower one is not having. Okay, this ray is having additional phase difference of pi. If there is already a phase difference of pi, I will say for minima, this has to be equal to lambda. Now write T comes out to be lambda divided by 2 mu. What is lambda? 550 divided by 2 into mu of which? Sheet na? This length I am taking. So that is 2. So this comes out to be 550 divided by 4. Let's go. Perfect. My exam will end on 27 March. Date scheduled is so perfect. Thanks. Yes, that's is done by our team. They take care of these things perfectly. Okay. If the measured angular separation between the second minima, now I am going to cover diffraction pattern. Okay. Second minima to the left of central maxima and third minima to the right of central maxima is 30 degree. Okay. Where is nth minima? Sin theta is equals to n lambda by a. This is for minima. Okay. So, second maxima. Here the central maxima is there. Okay. This is the sheet. So, second minima to the left. on one side you can take second minima. So here the second minima, how much is this angle? 2 lambda by A, second na. Third on the other side, how much is this angle? 3 lambda by A. And this total angle is given as 30. It means sum of this 2 lambda by A plus 3 lambda by A. So 5 lambda by A, this is given as 30 degree, means pi by 6. Lambda is given, I can find A, yes. So I can say A comes out to be 30 lambda divided by pi. 30 lambda is 628 nanometer divided by pi. I can do the calculations and write what is the value of A. Next question. We are increasing our speed. A microwave of wavelength 22 centimeter. What is the time now? It's 6:40. From 7 we have another session for maths. Okay, students. So 7 you have to come back. A microwave of wavelength 2 centimeter falls normally on a slit of width 4 centimeter. The angular spread of central maxima is. Central maxima is from first upper minima to first lower minima. The first upper minima is at sin theta lambda by A. Lower minima is also at sin theta lambda by A. Total spread comes out to be 2 lambda by A. Okay, this is for the total angular separation. I need angular separation only, yeah. So 2 into, what is lambda? Just a minute. Microwave of wavelength 2 centimeter falls normally on a slit width of 4 centimeter. Yeah, one thing is there here. One thing is there. What is that thing? We say the minima is at sin theta is equals to n lambda by A, nth minima. Okay, if lambda and A, the ratio of lambda by A is such that sin theta is very, very small, then we say sin theta is nearly equal to theta, then we write it like this. But here my lambda is 2, my A is 4, lambda and A are comparable. You cannot take sin theta is equals to theta here in this case. So you have to write sin theta only. Okay, here is the first minima. So sin theta, let us take here, sin theta is equals to lambda by A. What is lambda? 2 centimeter. What is A? 4 centimeter. This is 1 by 2. So this is 30 degree. Half angle is 30 degree. I need central maxima total. Okay, this. How much is this? 60 degree then. 30 plus 30, this is 60 degree. Option third is coming out. Getting it? Question. Orange light of wavelength this illuminates a single slit of width 6 into 10 to the power minus 4. Just few questions we will take and then I'll answer to the questions. All the questions simultaneously. The maximum possible number of diffraction minima produced on both sides of the slit is. Let us take at infinity, the order of the minima is nth. Okay, nth minima at infinity. At infinity, what is the angle? Pi by 2 at infinity. So I will say sin pi by 2 is equals to n lambda by A. Like this we write. So from here I will get order as A by lambda. What is A? A is this 6.6 into 10 to the power minus 4 divided by. What is lambda? This is the lambda. This is 6000 into 10 to the power minus 10. What it is now from here? This comes out to be 10 to the power 6. So 6 into 10 to the power 5 divided by 6000. This comes out to be 100. Yeah. So this order of the minima is 100. Same. Here the order of the minima is 100. But this 100th minima is at infinity. How many minima on the screen? On the screen 99 minimas on one side. Here on the screen 99 minimas. Total number of the minimas are 198. So we are having 198 number of total minimas. A beam of unpolarized light. Okay, now polarization question quickly. back to back. A beam of unpolarized light of intensity I node is passed through a Polaroid A and then another Polaroid B, which is oriented so that principal plane makes an angle of 45 degree relative to A. Okay, this is A, this is B. Here, this unpolarized light, intensity I node, here we know this will be I naught by 2. If the light is unpolarized, doesn't matter how the axis is oriented, it will be I naught by 2. Now, pass through another Polaroid. Here the angle is 45 degree between these two. This intensity will be I naught by 2 cos square of this angle. Okay, this comes out to be I naught by 4. So, this comes out to be I naught by 4, which is first option. Option 1, yes, perfect. Niladri Nath. As shown in the figure, 3 identical Polaroids. Okay, similar type of question. The path axis of P1 and P2 and P3 are inclined at 60 degree. Okay, here the angle is 60 degree and 90 degree with respect to the axis of P1. P3 is inclined at 90 degree with respect to P1. It means here the angle is 30 degree. Yeah, the angle between is like this. The source has intensity 256. What will be the intensity at point O? Let us take here the intensity is I naught. So, what that intensity will be? This is unpolarized. This will be I naught by 2. Half always. First it will become half. Then I naught by 2 cos square theta. What is this theta? Between these two angle is 60. So, cos square 60. Then again angle theta, I naught by this intensity into cos square theta. So, I naught by 2 cos square 60, this was cos square, okay, cos square 60 into cos square of this angle. Cos square of this angle is cos square theta, 30, this angle is 30, so cos square 30, like this. Now do the calculations. What it is now? This is I naught by 2 into cos square 60 is 1 by 4. Cos square 30 is 3 by 4 and this is given to us as 256. Oh, sorry, not this. I naught is given as 256. We need to find this intensity I. So, you put I naught as 256. 256 into 3 divided by 2 into 16 and then you can do the calculations here. Yes, 24, perfect, great. Deepak, trust me, exactly similar type of questions are there asked by advance also, no difference in the level. Okay, Brewster's law question, 2 statements. If the Brewster angle of the light propagating from air to glass is theta Brewster, how we write? We know for Brewster angle means theta, tan theta is equals to mu, we know. At that particular angle of incidence, the polarization happens. So, here it is mentioned for the light propagating from air to glass, so it will be mu glass, like this, mu glass divided by mu air you can say, okay, that is mu glass. Then the Brewster angle for light propagating from glass to air, if you say from glass to air, refractive index will be opposite, mu air divided by mu glass. Okay, then tan theta dash will be equal to 1 by mu glass. Simply, what has to be relation between these two? I know tan theta is equals to 1 by cot theta. It means theta and theta dash are having pi by 2, you can say, what should I say, theta plus theta dash has to be equal to pi by 2. Therefore, I can say theta dash has to be equal to pi by 2 minus initial angle theta. Yes, this is correct. Next, the Brewster angle for the light propagating from glass to air is from glass to air. Here it has to be mu air by mu glass. It has to be 1 by mu glass. This is incorrect. Glass to air. Okay. So, second medium divided by first medium you have to do, that is this actually. This is not tan inverse mu g, this is tan inverse 1 by mu g. So, this is incorrect. I will say first statement is true and second statement is false. Option 4 is coming out to be correct. Okay, Great. We did 40 questions, and these 40 were very important questions. If you did all the 40 questions, it means your concepts of ray optics and wave optics are clear. Okay. If you are able to understand all 40 questions, solve all 40 questions, good. Now you can prepare for the other topics. These 40 questions were selected, okay, which covers everything. Now questions. Sir, solving all rank booster series is enough for April attempt? In rank booster series, certainly we have tried to touch all the topics, all the varieties also you have seen. So what you can do is rank booster series plus all the questions of 2026 January attempt nicely. And if there is any backlog, cover those backlog only. Okay, that will be sufficient for you as of now. Sir, lecture batch is for JEE mains or JEE advance? You do separate preparation for mains and advance? You do like that? I did a combined preparation only. Like we are preparing for JEE mains and advance simultaneously only. Okay. So it is for both mains and advance. It's not that for mains there will be separate batch, for advance there will be separate. No, nobody prepare like that. In my time when I was preparing, it was a combined batch only for mains and advance. Yes. We will be doing questions of mains, of level of mains, and of advance also, and few questions above the advance also. So everything I will be taking care, don't worry about that. Okay. So lot of practice of mains plus advance, it will be a combination of that. When we start building up concept, first we go for mains. Okay. So basics we will do, fundamentals we will do. Once the fundamentals are stronger, okay, then we do some other questions of good level, like that it starts. So when I start, let us take I start kinematics. It's not that in the first session only I'll be touching the peaks of G advance. Sir, atom and nuclei next session. Yes, in the next session I'll be taking the 40 selected questions from modern physics and semiconductor. Modern physics 3 chapters we have. Okay, dual nature, atom, nuclei, and the last semiconductor. It will be a combination of the two. Arpan, both S1, S2 are false. No, S1 was true. I think you did some mistake. Please check. Okay, guys, we will have now math session in a while. So it's a 10-minute break almost. So 7 p.m. Deependra sir will be there. And yes, Deependra sir will be taking 40 powerful questions from maths. Yesterday also there was a session by Deependra sir. Now try to understand these 40 selected questions are very important. Don't miss these discussions. These are short discussions. Okay. Previously we were taking longer discussions. So I think many of you were not able to attend those discussions. Now it's, you can say, cream of that. Okay. Bye. We'll see you again sharp at 7 p.m. with Deependra sir. Bye-bye. We are ending this session.